Watch it move. It's in motion. Motion. Watch it move. It's in motion. It takes force to start. Stop. Bounce. Smash. Turn. Throw. Kick. Squeeze. Speed up. Slow down. It takes force to jump. Run. Push. Pull. Open. Close. Fall down. Watch it move. It's in motion. Motion. Watch it move. It's in motion. Motion.
Impact is what happens when one object hits another object. Bouncing is one kind of impact. Smashing is another kind. This is impact too, but it's fake. It looks real, but these actors are only pretending to fight. If they weren't, they'd get hurt from the impact of their bodies hitting each other. We all know a lot about impact, and we expect certain things to happen when we see impact. If the actors do what we expect, like fall down, they create the illusion of impact, even when there isn't any.
1, 2, 3, 4, 5.
And that's what Robin, Mary, and Paco are going to learn how to do. Create the illusion of impact.
Let's do another exercise. Bring your hands up like that. Bend your legs. Down
That's
like
B.H.
that.
Barry, an impact specialist. He's going to teach them some tricks. The first thing you have to do is warm up.
Now, I'm pretty hot already. So what do you mean by warming up?
When you're doing a warm-up, what you're doing is sort of protecting the muscles against strain and impact.
What's impact?
Impact is when two objects hit each other. Take your hands like that. Now bang them together. Ow! Right? Ow is a noise that's made from impact as well. Okay, it also makes other noises, like when you clap your hands. That's impact. I'll show you. My body hitting the floor is impact.
Oh,
Yeah?
Did you hurt yourself?
No.
are you sure?
Well, I'll check it out. Let me see.
Oh, my
All right, okay. Let me show you something else about impact and how the body deals with impact. I'm going to jump off this chair. Now, I'm not going to do anything about the impact. I'm not going to let my body do anything. And my body kind of hits the floor, and the bones go on top of each other. But there's another way of doing it. If I absorb the force of my jump, watch what happens. The body actually bends and acts like a big car spring. It just bends and absorbs the force as I fall forward.
By bending his knees, B.H. slows down the impact, and this puts less strain on his body. Changing shape, or bending your knees like this, is a form of distortion. B.H. showed them two different kinds of distortion.
Got two balls. I drop this one, and it bounces right back up again. Now, what it's doing when it's bouncing is it's actually, as it hits the floor, it's distorting. It's kind of pressing in, and then it's coming back to its original shape and shooting up back towards my hand again.
So when you say distortion, you mean it changes shape?
Changes shape, that's
And
true.
it changes right back.
Yeah, but watch this one. That changed shape, and I don't think it's going to bounce back again.
No, because
That's what the
it's
body
clay.
does sometimes, huh? It's made of clay, yeah? Okay, there's the clay, and there's the ball.
A rubber ball has elastic distortion. It changes shape when it hits the floor, then it changes back. The clay ball has non-elastic distortion. It doesn't change back. You have to understand both kinds of distortion to create the illusion of someone falling on the floor really hard, like this.
Oh,
How about that?
you didn't hurt yourself?
No, I wouldn't do it all the time if I was
Looks
going to
like you did.
B.H. rolls forward on the muscles of his back. See how he supports his weight on his hand and his feet as he pushes himself forward? It looks like he's hitting really hard, but the impact is slowed down and spread out across his whole body.
Could we do something like that?
Sure.
B.H. taught them how to feint.
So let me see. If you start here, like that, move a little further, Paco.
He showed them how to use their muscles to slow down the fall.
That's good.
No one got hurt, and it still looked real.
Just drop your knee down to the floor. Just do that first. That's good. Now turn and face the other direction. Keep turning, and let yourself fall backwards without moving your foot. Good. There you go. So you fall backward downwards. And what's happening, do it one more time. Can you hop up, Michael, and I'll demonstrate with you. Get your feet apart. Put your knee on the floor, slowly. Now leave your knee there. Now what's happening is you sit, let yourself fall forward. Reach forward, that way.
Forward?
There you go. And your body goes down onto the ground. Right? Of course you can. Try that. Let's see you do it, Mary. Onto your knee. Right, okay, it's got to go right onto your knee. Turn. Keep turning. And you fall down onto your back. Now you've got to leave your feet down. When you faint, your feet stay on the ground. Okay. When you faint, your head, that's right, your head starts to go first, right? And your knees go softly, like that. And you let yourself twist to the ground. So you build up the audience's expectation of you about to fall. Try that. So let your heads go. Faint. Yes, there it is. Good. Now you're all doing one thing which you can improve on.
What?
You're putting your hands down just before you hit the floor.
Oh, dear.
Watch. If I put my hands down as I hit the floor, it looks like I'm protecting myself. You don't need your hand. Watch now. Without my hands, imagine.
Oh, so hold like
Yeah, like hold your head. Oh, you go, try that. Let your head go. Yes, good. You put your hands down on the floor. Good.
How's this?
Now hold it to your head. Keep on your head, Mary. Keep on your head, keep on your head, keep on your head. Yes, that's it. Leave your feet down.
Let me try.
Go on, try it. That's it. Yeah? You don't need them. Hold on to your head the whole time. Like that. Okay, let your knees bend.
Don't let go of your head.
Don't let go of your head. Well, your instincts are to put your hand down the ground to break your fall. What you have to do is to overcome those instincts. Put your hands on your head. Let your knee drop to the ground. There, keep turning. That's it. Shall we all try together?
Sure.
Let's all do it at the same time.
All right.
Right, ready? After 3. So what we're going to do is 1, we'll hold our heads. 2, you let your head go. And 3, we'll fall on the floor.
Okay.
Ready? You won $1 million. 1, 2.
He's not really hitting the pole. He's creating the illusion of impact.
I spend my life teaching actors how to do this kind of stuff. I teach them how to fight. And they often, when they fight, have to use other objects besides the floor. They could use, they may have to hit a piano, yeah? Or they may have to hit a wall, or things like this. We could, I don't know, what else do we do?
What about the black? Oh, man.
Bump into a blackboard.
Did that hurt?
Nuh-uh. I'll show you actually how I do it, shall I?
Yeah.
Watch, in slow motion. My hand hits, and I react to it. Now, it's the reaction that counts. You have an expectation of what happens when an object hits another object.
Like your head swings back.
That's right. If I don't swing back, watch what happens now.
Looks fake.
Right. So I'm dealing with that illusion, that kind of sense of reality.
There's no real impact in a stage fight. It's all a trick. If a punch really connected, the actors would get hurt.
We create the illusion of a punch. We don't actually do it. Because if you did hit with my face, what would really happen would be your fist would hit my face would distort, going through like that, and you'd hurt your fist too, right?
Yeah.
Right, so this is all just a kind of a fake
So
thing.
my hand is not actually going to impact with your jaw.
Absolutely, but we hope it doesn't, all right? Okay, so let's do that again very slowly. Bring your fist forward, clunk, and my face turns and distorts. It will look silly if it went in the other direction. You do it very slowly again. Bring your fist forward, yeah? That would look kind of stupid.
Right.
Even better, throw your punch at my chin. It would look as if I was walking into it. So my head has to go in this. Let's do that one again. And the head moves up in the same direction. So direction of force is important. Okay, now, let's try it again. Now, this time, instead of hitting my chin, like this, take your fist and swing it so you miss my chin. Just do that. Aim to miss. Right the way through. Now my head's going to turn. Do it one more time.
Okay.
Yeah? And again, big swing. Now, you should be able to see that there's a gap, or if the audience were looking at it this way, or from here, they would see that there's a gap.
So they could see that I really didn't hit you.
That's true. If I move this way now, so the audience is behind me, and you move that way a little bit more, now throw your punch again.
Oh, so they can't really
They can't see the gap.
that I don't hit you.
Try it.
Okay.
And the head turns. So we create the illusion that it's made. There's no noise there yet, though. We need a sound.
Can I make it?
You can make it, or I can make it.
Okay, let me hear what it sounds like.
All right, okay, you do it. And
Oh, you make it with your hand.
I made it with my hands. Throw it slower.
Okay.
B8 showed Robin why a stage punch looks so real. His head turns in the direction of a swing, and he reacts. He pretends that he's been hit.
You want to learn to do a kick?
A real kick?
No, just a pretend one, like the punch was. What we're gonna do
A kick is impact, too. B8 showed Paco how a stage kick gives the illusion of impact.
Very slowly, Paco, so that I don't lose my leg. Well, instead of kicking me, when you would normally do a kick like this, can you put your hand on my shoulder? Bring your foot up. Instead of kicking me with your toe, you're going to kick me with that flat part there. And you see, if I push on it, see it's got a spring in it?
Yeah.
So that kind of takes some of the force out of the kick.
So I'll kick you like that?
Yeah, and instead of kicking me right in the hard part behind the knee, kick me more in the back, on the thigh.
On the
there,
muscle,
on the
right.
muscle at the back there.
All right.
And there's something else you're going to do as well.
Oh.
As you kick the back of my leg, you pull your foot back.
that?
That's it. You pull it back. Just kick my hand to start with. Just do that. Yes, that's it. So you're not transferring any of the force. Do it again. Boom! Right. Okay, now take your foot right back as if you're making a very big movement, like with the punch, a big movement.
So it looks like you're kicking harder.
That's right. Take it right back. There! Okay, now try the back of my leg. Bang! And I relax. Now watch what happens now. Is from this position, do you recognize this bit?
The fainting.
The fainting movement. There's the back of my leg, and you can keep there. Let's do it one more time. Ready? I'm running in, I'm coming this way, there's my leg. Oh, and there's my leg. Good. You kicked me over. You were very casual as you did that. Grab my hair for real. Mind the
Mary found out how to create the illusion of hair
Hold on
pulling.
tight there. What you would do if you squeeze my hair, wouldn't you, yeah? And what I try to do is move your hands away from it, so the battle would be between you holding on tight to my hair and me trying to pull your hands off. Also, what you would try to do is to move my head around, yeah? That one which would make that hurt me. Now, we're going to reverse everything I just said, all right? So instead of you grabbing hold of my hair and squeezing my hair,
Pull out.
you pull out, and I'll hold your hands to my head. So you pull outwards, and if we let go, it should all fly apart. Ready? And it all comes apart, making it safe. All right? Now, there's one thing more added to that. Instead of you moving my head around, I'm going to move my own head around, all right?
Okay.
So it'll look like you're actually moving me around, right? You keep yourself still. Ready? Here it goes. Oh, God, that's... Oh, let go of me. How about that then, huh? You want to do something else?
Okay, right.
Let me do that from behind you. So if I crept up behind you and I grabbed your hair, hold my hands, like that, yeah? So you're in control of it. Hold it tight, hold my hand tight. All right, I'll make it look strong like that. Now you're going to do something to get out of it. And we're going to do what's called a throw. Do you remember I did that fall over? I rolled over and landed on my back. Let me show you how you can put these two things together. Let's move back a little bit like that. Take hold of my hand. Now, duck underneath here like this. Keep turning, hold on to my hand. Lift your hands above your head, and... Whoa! Now, creep up behind me. Grab my hair at the back, and pull me along the ground. Just pull me backwards. That's it. And I'm going to walk until... You've got to stand up, not fall over. Right, go on, keep going, and pull back. From there. You got the idea? Let's try the whole thing, shall we?
Okay.
You're standing there, and I'm going to creep up behind you. Right, Mary. Grab. Hold my hands. Turn round in a circle like that. You lift your hands above your head. You throw me over. Ah!
Are you okay?
Yeah, I'm fine. That sounds like fun, doesn't it? All right, let's try and put all the things that we've done together. We do your throw, your hair pulling, your kick, Paco, and your punch, Robin. Stick it up behind you there. Grab you by the hair. That's it. Just stand up right there. Good. Oh! My leg. Oh! Kick there, and again. Oh! Right. Now move back. Mary, you start to run. When I grab your hair, hold my hand, come back to the center here, swing round in a circle, round you go, lift your hands up, and... Oh, grab my hair! There, grab me! No! Grab my hair! Oh, no! Don't grab me! That's it, take me towards the blackboard! You guys all right? I was only joking.
Yeah!
guys are getting very good.
Stage fighting isn't real fighting, it's an illusion. The illusion of impact.
Up in the air.
A moving object will stay in motion until something stops it. When you're riding in a car, you're moving at the same speed as the car. And if the car stops because it runs into something and you're not wearing a seatbelt, you will keep moving. Just like one of these eggs. This is the United States. For our next story, we go to France. This is impact, too. And just as we need to protect our bodies from the effects of impact, sometimes it's necessary to protect trains, too. This is a collision research laboratory at Vitry-sur-Seine, near Paris. Chantal is here, finding out what happens when train cars collide. That's Mr. Collot, an engineer.
Vous allez casser les wagons?
Non, n'ayez crainte. On est au centre d'essai et on fait des tests sur les wagons.
Don't worry, this isn't an accident. This is just a place where they have experiments to see how trains react to collisions. And now Mr. Collot's going to tell us some more about it.
Tu vois, Chantal, c'est grâce à ces tampons que les wagons ne se cassent pas. Ça sert à la fois de ressort et d'amortisseur.
So this is a buffer. And this buffer is the reason that those two cars we saw before didn't just crash into a million pieces. This buffer is very, very solid because those cars, even though they were only going 10 miles an hour, were both charged with 80 tons. Can you imagine 80 tons coming at each other, and all because of this buffer, it didn't break? This up here is a captor. Now, usually they don't have these on regular trains, but this is the SNCF, which is a French railways company, and they're having experiments here. So this is related to the computer, and it determines how far the buffer goes in when the collision takes place.
Mr. Collot took Chantal to find out what's inside the buffer.
Tu vois, ce sont les trois parties du tampon. La partie mobile, la partie fixe et le ressort.
So these are the three parts of the buffer. This is the mobile part, this is the static part, and this is the spring. Et ça, qu'est-ce que c'est?
Alors, ceci, c'est une partie de ce ressort, c'est une des rondelles qui est faite en caoutchouc très dur et qui frotte sur de l'acier quand on le comprime.
So this spring is inside the static part, and this is one of the discs that make up the spring, and it's made with really hard rubber. And what happens is that when all the discs in the buffer are pressed together, they change shape, and that's how they absorb part of the energy that's coming from the other train.
Chantal turned on the machine that tests the buffers.
On reproduit le mouvement de ce qui se passe au moment du choc dans le tampon. Ça la comprime le ressort et il se détend ensuite. C'est comme ça que l'énergie est absorbée par le tampon.
So this machine represents what happens when the actual collision takes place. This is the buffer, and these are the discs. Now, when the shock occurs, the discs get pressed together, and therefore they absorb some of the energy from the train that is arriving. When the train was hit, it kept on moving. That means that part of the energy from the first train was transferred to the second train.
This is the control room. It's where they monitor everything that happens when the trains hit each other.
In this place, they measure the speed of the wagon, and since they know how much the wagon weighs, they can figure out the total amount of energy at the time of the collision. What they're trying to do here is conduct experiments to see how good a buffer they could make so that when trains are traveling with merchandise, they'll have a lot less of a chance of breaking if they bump into each other.
Trains sometimes run into each other. Research like this helps us know how to protect things from the force of impact. It's the coefficient of restitution show! Why do things bounce? Exactly what is bounciness? Interesting questions. Let's see if we can find some interesting answers. If one were to drop a tennis ball, it would bounce back quite handily from the floor. What's happening here? Well, a falling object has energy, and when it hits something, it stops. Boom. But what happens to the energy? It doesn't just disappear, it has to go someplace, right? Well, the energy goes into changing the shape of the ball. It gets pushed in, like this. But check this out. If I let go, the stored energy returns the ball to its original shape. That's what pushes it off the floor. Most people call this bouncing. Scientists, on the other hand, call restoring the original shape restitution. And the amount of bounciness a ball has is called its coefficient of restitution. Now, we can measure bounciness by comparing how high a ball bounces with where it was dropped from. If it bounces all the way back, we say it has a coefficient of restitution of 1. Let's see if any balls can do that. We'll start with the rubber ball. Remember, you can't throw the ball because that would change the bounce. You have to drop it. The coefficient of restitution is 0.67. Tennis ball. .57. The ping pong ball. .6. The hard ball. .24. Beach ball. .4. The marble. .38. Super Bowl. .84. As you've seen, none of these balls had a coefficient of restitution of 1. In fact, in the real world, nothing does. You always lose some energy on impact. But the winner, the ball with the highest coefficient of restitution, the ball with the most bounce is Super Bowl! Congratulations. A kangaroo is like a rubber ball. Each time it lands on the ground, part of the force of the impact is stored in its legs. And when it begins its next jump, it uses the stored energy in its legs to push it back off the ground.
The force of gravity pulls me down. The force of the impact distorts the trampoline. And the stored energy pushes me back up in the air. To stop, I absorb the energy by bending my legs.
Sometimes something you do when you're a kid can change the whole way you look at things. Linus Pauling is a chemist. He's the only person ever to win 2 Nobel Prizes.
80 years ago, when I was 5 years old, I received my first lesson in science. I was living in a small town in eastern Oregon full of cowboys. Someone had given me a knife, and I was downtown by Main Street, which was a muddy street, not paved, trying to sharpen a pencil, but not succeeding. A cowboy said, "You're not doing it right. You must think about it. First, hold the knife firmly, and then select the angle at which you want to make the cuts, and keep to that angle. And make one cut, rotate the pencil, make another cut, and you'll succeed." That was my first lesson in science, in rational thinking. I hope that all of you will study science and mathematics and be able to appreciate the wonders of this modern world.
Bouncing and smashing are different kinds of impact. Some animals use the force of impact to help them move. We can protect ourselves from the force of impact by bending our knees, or rolling, or using restraints like seat belts. Different objects have different amounts of bounciness. We can measure how much bounciness something has by dropping it. Bouncing or smashing, it's all impact. Three 2-1 Contact is a production of the Children's Television Workshop and FR3.